Josh Perry says, I'd love to see a deep dive into the Martian Color Wheel, so let's jump in. This chart was created by Warren Mars in 2014, with some minor corrections in the early 2020s. His key justification for the project was that we don't have reliable names for most digital colors, and that's a real problem. It's actually a grievance with a long history. Over 100 years ago, it was the same reason for Albert Munsell to start. He complained about the same lack of color naming standards in the foreword to his 1905 book, A Color Notation. And a century before that, Patrick Syme expanded Verner's nomenclature of mineral colors to include plants and animals as concrete references for hundreds of shades of colors. Warren Mars adds to this tradition by extending it to the realm of RGB colors, and you can see if you look at his color names, he put a lot of thought and time into the project. To me, it's a bit quixotic in 2014 to spend so much time compiling these kinds of digital color names in isolation, especially considering how no two displays are quite the same. But I do find the other part of Mars's project very intriguing, and that was his attempt to build a more perceptually even version of HSL. He correctly assessed that the steps between hues in the HSL circle were warped and uneven. It makes sense. Computer colors are additively mixed in a triangle between red, green, and blue subpixels. So say you take equal steps around a triangle. Near the corners, the lines end up closer together. It becomes more obvious with a circle inscribed, and this is effectively what happens around red, green, and blue in HSL. The hues are closer together even though we're taking even steps all around the perimeter of the triangle. And a perceptually even hue circle, on the other hand, would make sure that the amount of perceived difference between each hue step is about the same visually. So to sum up, here are 24 even steps in HSL, and here are Mars's 24 perceptually even steps for comparison. Again, you see the clustering of HSL hues around red, green, and blue. Mars also makes a point to correct for a known issue, the Abney Effect, which we talked about in the previous episode. This is what they call it when a color, desaturated with white, shifts in hue. On screens, the Abney Effect is most pronounced with blue. See how it gets a bit purpler as it gets lighter. Mars corrected for this in choosing his tints for the wheel. His vivid blue is hue angle 240, but his light blue is 235. He made other corrections and updates in the early 2020s, and you can read his full documentation on his website. In the end, the scientific framing for Mars's color wheel is valid, but his corrections are just sort of idiosyncratic. He fiddled with values and said, yeah, that looks good to me, and moved on to the next swatch. He eyeballed it, which is fine, and in fact justifiable in 2014. At that time, the only perceptual color space tool for digital designers was Alexei Borodin's hslove.org, and it hadn't yet seen wide adoption, so there was a real need for solutions. But then OKLCH arrived in 2020. It's a perceptual system that solves the spacing problem computationally, and Google created HCT, a perceptual space for UI design, about a year later, around 2021. Warren Mars ends up, in my mind, as a kind of garage color scientist, building a perceptual digital color space by hand, with like a handsaw and a power drill. Pretty cool, and for a nerd like me, a pretty relatable project, even if it was superseded by more rigorous solutions in just a few years. Thanks again to Josh for suggesting the Martian Color Wheel. What other color wheels should I discuss on Color Wheel Wednesday? Leave a comment.